Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this video we're going to continue our look into clustering, and particularly looking at the k-means algorithm. Now if we just do a quick recap from the previous video, we can just open up the results of our previous analysis. We can see that we identified 3 different clusters based on 4 different variables looking at 150 customers. So for example, if we're to look at the income and loyalty by customer and to plot that as a scatter, there we can see that's actually some of the input data, and then to see the clusters we created, now we can see those are the 3 clusters. And the cluster number, effectively that's known as K within the k-means. Now one of the big challenges associated with doing cluster analysis is to decide what is the best number of K. What is the best number of clusters that you want to create? What naturally fits the data the best? Well, the PAL library gives you some help with that, because there is an additional capability that goes alongside k-means which will produce you a setting which is known as the silhouette. It's effectively a measure of the quality, how good the cluster analysis has been. So the silhouette has a value typically from between 0 and 1, or it can go from -1 to 1. And what the silhouette basically tells you, the closer the value of silhouette is to 1, the better the overall fit of the clusters is to the data. Now it's actually quite easy to understand silhouette if you actually ran a cluster analysis on 150 customers and you asked for 150 clusters. Every data point would be exactly on the center of its cluster, because it would make 1 cluster per data point. In that case, the silhouette value for the data set would be 1, because everything fits directly, it's just perfectly aligned. However, in the real world, maybe you're creating 3, 5 or 10 clusters, then you're going to be wanting to look at, of those number of clusters, how close are the individual customers to the center of those clusters, and the higher the value of the silhouette, effectively the better the value, the better the clustering that's been performed. In fact, typically as a rule of thumb, if the silhouette value is less than 0.2, it's probably pretty poor fit, whereas if it's greater than 0.5, that's a pretty good fit for the overall clustering. So we're looking for high values of silhouette. So we've already performed a clustering analysis. We want to now look at what's the silhouette value for this clustering we already performed. Well, what we need to do there is to call another procedure which is based around the validate k-means part of the predictive analysis library. So similar to what we already did, of course we still need the work we did on k-means. This is additional. What we're going to do is create a new procedure called pal_km_v for validate k-means, which will give us the silhouette value. And again, as always, more details on the exact syntax and the parameters for this in the PAL reference guide. But what we can see, we're using the validate k-means as input. We also need to provide input to this the results of our k-means analysis. So in that case, that's the second input table. We also need to provide the original source data, so we must have done the k-means already, and we give it some parameters and we will get out a results table which will have basically 1 column and 1 row, which will be this silhouette value that we want to see. So let's go ahead and generate that procedure in the _sys_AFL library. That's now been created. We want to bring in the original results, or the results that we got from the pre-k-means run, and put that as input. Now, in fact, there is a specific that we typically to name as type assign that value. So what we've done here is from the results table we've created a view. However, if you wanted in your original results, you could have called it type assign, then you wouldn't need to make any change. And also, there's the center distance, which we don't need for this analysis. So in this view, we've not used that column. Then we create a parameter table for the k-means validate and a result table based on the types, the table types we already did. And there's a couple of parameters, basically the number of threads and the number of variables we were looking at. In this case, in our analysis, we were looking at 4 input variables. So let's now run that to set up. We run that code. And now actually for our runtime, we've not run this already, so no need to truncate the table. We can simply go ahead and run our k-means validate analysis. So that analysis runs. It takes just a couple of seconds, not even that long. And if we now go and refresh our list of tables, we will see we've got some new tables, and the one that's of interest to us is the k-means km_v_results. So that's the table that's got our S value in it. And if we look, there we go, we can see one row, one column, the value of the silhouette is 0.56148. So actually that's above 0.5, so that means that when we do 3 different clusters, we use a k value of 3, that gives us a fairly good grouping. So that seems to make sense. Now what if we were just to try another example? Let's go back to our original k-means from the previous video. What we're simply going to do here is maybe set the number of clusters to, for example, 5, and we'll empty the results and we'll run the original k-means analysis again. So that runs very, very quickly. And then what we can do is again run our validation on that. Again, we just simply need to run it. It's automatically going to get the results from that previous run of the k-means. Just empty our results with the silhouette. We run that. And now if we refresh, the k value is a little bit less. So when we run with 5 clusters, so value of k equals 5, then the silhouette is not quite so good. So 5 clusters is not such a good fit as 3. So that shows you the idea of how you can approach looking at how good the clusters that you've created here, how well it fits the data overall. And it seems in this case that 3 is a pretty good fit. We validate that with the silhouette value. Now what you could also do, you could maybe try to automate some of this process. Because HANA is so powerful, it can run these analyses very, very quickly on very large volumes of data. You could maybe set up in your application a little loop that actually would go and run the k-means and run the k-means validate, maybe for a whole set of k numbers. For example, run it from 2, 3, 4, 5, go all the way up to 10 or 20 values of k, and then simply look at the results of that, look at all the different S values, the silhouette values, and look at which has the highest silhouette value. And that will give you a good indication by crunching through all the possibilities of what the best natural fit, what the best value of the number of customer segments should be.